finding the relative minimum and maximum of this function. So the steps that we will be follow is, first of all, we will find f prime of x, and then we will set that equals to 0 to find the critical numbers, and then we build our test intervals, and then we test each interval, and then we draw our conclusion. Let's get started. So the first step is we are looking for f prime of x because we are trying to analyze the slope. So f prime of x, you bring the 4 down, so the fraction is gone, you have x to the third, and then you bring the 3 down, the denominator is gone, you have 5x squared, bring the 2 down, you have minus 4x, and then the derivative of the linear term is negative 20. All right, so now the derivative is done. What is this mean, f prime of x? So this is one function to describe the slope of f. So this is the slope of the given function f at any x value. And then we have to set that equals to 0. I would like you to write this down, set that equals to 0. Why? Because we are looking for horizontal tangent. So suppose we have a parabola, and then this is my minimum. At this point, we have a horizontal tangent. At the horizontal tangent, the slope is equals to 0. That's why we have to set the derivative equals to 0 to find horizontal tangent. All right, let's do the work. So once you set that equals to 0, and then you have to do some factor to get the critical numbers, right? So I would like to do factor by groups. So I would like to group the first two terms. So that is x to the third plus 5x squared. And then the next two terms minus 4x minus 20 equals to 0. So am I doing this right or am I doing this wrong? If I am doing this wrong, where is the mistake? The mistake is I have to change the minus 20 to a positive 20 because I just put a parenthesis to group the last two terms. So once you distribute the negative, then you have your minus 20. And then you factor, right? And then you factor out an x squared. So this is a x plus 5. And then this I will factor out a 4. So you have a x plus 5. So since they both share x plus 5 in common, let's factor it out. So you have x plus 5. And then multiply x squared minus 4. You have that equals to 0. So don't forget to write a 0. I want you to do this line by line. And then you're doing another factor. So that is x plus 5. And then this one is x plus 2, x minus 2 equals to 0. Then our critical numbers are x equals to negative 5, x equals to negative 2, and x equals to positive 2 using zero product property. I know this is a fundamental thing, but when you apply zero product property, make sure the other side is equals to 0. If the other side is equals to anything not 0, then you cannot apply zero product property, all right? So you have multiple factors, multiply them, that is equals to 0. That means either one of these factors has to be equal to 0. So that's how we got this value. All right, make sure the other side is equals to 0. And then this has names. They are critical numbers. So critical numbers. Some textbooks call them critical values. So critical numbers, critical values, they are the same thing. And then you drop these three numbers on a real number line. So let's do this in another color. So you drop them on a number line. So we draw a number line. You are taking a calculus class. I assume you know what a number line is. So we have a negative 5, negative 2, 2 number line, 0 in the middle, negative on the left, positive on the right, right? As you go more and more to the right, the numbers are getting bigger and bigger, and then you go all the way to the end, you have a positive infinity. Remember that? So this is from negative infinity to negative 5, and then from negative 5 to negative 2, and then from negative 2 to 2, and then from 2 to positive infinity. And then this is your test intervals, all right? Test intervals. So let's put the test interval right over there. From negative infinity to negative 5, and then from negative 5 to negative 2, and then from negative 2 to positive 2, and then from positive 2 to positive infinity, and then we are ready for the next stage. So the next stage, you have to test each interval. So let's change color. So how do we do the test value things? So you are going to pick a value inside each interval. So the first one, I would just pick x equals to negative 6. So test value, I would just put x equals to negative 6. Negative 6 is inside the interval, right? Can you pick x equals to negative 1,000? Of course. But if you pick x equals to 1,000, when you plug in x to the f prime, you get a lot of work to do. And then the next one, I will just put x equals to, how about negative 3? Easy, right? This one, x equals to 0, x equals to 3. I always pick easy numbers. I haven't seen anyone on my test picking a large number to, to make a challenge in the middle of a test. Okay, f prime of x. So for f prime of x, for the first test value, so here is what you have to do. So you will doing f prime of negative 6. So that is a negative 6 raised to the third plus 5 times negative 6 squared minus 4 times negative 6 and then minus 20. So this is equals to negative 22. Negative 32. And then some student asked me this in the past. They said that, why don't we just put this in the factor form? That makes everything easier. Of course, you can either plug it into the very beginning or you can plug that into the factor form. It doesn't matter which one you use because they are the same thing. One is before factor, one is after factor. So you can just plug in negative 6 to the factor form to make the math easier. So in this one, I don't care if that is equals to negative 32 or negative 3000. One thing that I care about the most is this is negative. Negative, that's what I care about the most. And then you put that to the table. So f prime of negative 6 is negative. And then for negative 3, so f prime of negative 3, so you have negative 3 to the third plus 5 times negative 3 squared minus 4 times negative 3 minus 20. So this one is equals to 10, positive. So f prime of negative 3 is greater than 0. And then f of 0, easy. So f prime of 0 is equals to negative 20. So that is less than 0. And then f prime of 3, so this one is equals to 40. I already did the math. That is greater than 0. So listen to my advice. Please use your calculator and do it correctly. For example, make sure the negative 6 is inside the parenthesis before you take the third power. You already did a lot of work. It is not worth it to mess up at this stage. All right, you are almost done. It is not worth it to mess up this. If you mess up any of this testing, you will get a real conclusion. All right. And then let's jump to the conclusion. What is negative slope mean? Negative slope means the curve is going down, so decreasing. Positive slope going up, increasing. Negative slope decreasing. And then positive slope increasing. So for decrease, increase, what do we have? So going down, going up, we have a minimum, right? And then at this point, this is x equals to negative 5, x equals to negative 2, x equals to 2. And then up and down, we have a maximum. Down and up, we have a minimum. So we just get all the relative min and relative max. Okay, so that's how you do it. And this is your conclusion. And then, so now we have the relative min and the relative max. My next question is, tell me the location of each max and min. So how do you find the location? Let's do that in another color. I want to find the location of max and min. For example, here, how do you find the location? So to find the location, where do you plug in? Do you plug it into f or f prime? You have to plug it into f of x. So which is f of x when x is equals to negative 5, right? So when x is equals to negative 5, you have 1 over 4th, negative 5 to the 4th, and then plus 5 over 3, and then negative 5 to the 3rd, and then minus 2 times negative 5 square, and then minus 20 times negative 5. So let me say this one more time. When you are analyzing slope, you plug numbers into the f prime. When you are looking for a point on the curve, you plug it into f of x. F of x is location of a point. F prime of x describes the slope of the given function. All right. So, and then you plug it in, you will get negative 2.083. I prefer to just use a decimal because you don't want to do the common denominator thing, right? So f of negative 2 is equals to 22.667, and then f of 2 is equals to negative 30.667. So let me give you a picture to summarize all the work because no picture, no truth, right? All right, here is a picture. So let's take a look. So this, what is the graph stands for? What is the red line stands for? The red line stands for f of x. This is the red line. Do you see a curve? Looks like a W. So going down, up, right? So that is f of x. And then we have the graph. And then where is the first point? The first point is when x is equals to -5, -2.083. This is a what? This is a minimum, right? This is a minimum, just like what you wrote on the table. And then max, the next point is max, and then the last point is min. So this is a min, and then this is a max, and then this is a min, right? And then the next point is -2, 22.667 is the max, and then the last point, 2, -30.667, that is the local minimum or relative minimum, right? It doesn't matter which word you use, relative or local. All right, that is the end of this problem and also the end of this video. If you think my instruction is clear and helpful, give me a like, share the video in any social media for me. Click the subscribe button if you are new to the channel. I will catch you all in the next lesson for more examples and concepts. Signing out.